dielectric, dielectric with a dielectric constant of 2, what changes? Or what stays the same?
Capacitance will double.
Okay, so those would be 2 times what we started with.
Electric field stays the same.
Which I have 2 different electric fields.
Total.
Electric field of the plates will go up. The electric field of the plates will increase.
Why? Well, wait, before I harass you with that, why is the total electric field going to stay the same?
If you want to do it mathematically,
Yeah.
Electric fields. What now? Never mind. Oh, it would be independent of.
So you're changing your mind on that? All right, let's back up again. Why is this doubled?
Because kappa is doubled.
Yeah. If we look at this equation over here, kappa went from 1 to 2, area stayed the same, the distance stayed the same, epsilons did not stay the same. So it doubled because of, we can mathematically that equation. So we have that equation dealing with parallel plate. That's, again, this is specific to parallel plate capacitors where the distance between the plates is small compared to the size of the plates. And this is always true. Another equation that we have, that the electric field strength from just the plates is sigma over epsilon sub naught. The electric field total strength is the voltage divided by the distance between them. Or sigma over kappa epsilon sub naught. Wait. That. Yeah, that was right. Sigma over kappa epsilon sub naught.
Electric field total decreases, electric of the plate stays the same.
Sorry, say it again, start again.
The electric field of the total decreases while the electric field of the plate stay the same. Main capacity.
Why would the total decrease?
Kappa is increased.
Yeah, you're assuming that sigma and epsilon naught are staying the same?
Correct. Would it not?
No, the charge is gonna change on the plates. So looking at this right here, did we change the voltage?
No.
Did we change the distance between the plates? The total electric field is indeed the same, you were right before. Believe in yourself. All right, so from the plates, well, actually we can do charge now. Voltage stayed the same because it's still connected to the battery. What happens to the charge on the plates?
Increases since voltage is staying the same.
Yeah, that stays the same. This is double. Charge has to double. And so the electric field from the plates
Has to.
Increase.
Yes.
by
2.
yeah. So we start out with an electric field like that, E sub naught. Now we have twice coming from the plates, 2 E sub naught that way, and we're gonna have the sort of a back. That would be the electric field from the dielectric, so that the total stays the same. Let's disconnect. Dielectric is still in there. What changes?
Voltage is no longer the same.
No, voltage stays the same.
Oh, we disconnected it perfectly?
Yeah.
Okay. Voltage is the same.
Charge stays the same, voltage stays the same. Electric field total stays the same, electric plate increases.
If the charge stays the same, why would
Everything just stays the same.
Yeah, everything, all I've done is disconnected, we haven't changed anything else, so it's all the same. Let's now. Cut D in half. No, let's. Let's third D. I looked this up, yesterday, day before. If you cut something in half, you have it. If you have something, it cuts in half. And I looked up if you want a third of it. And there is, it's in the OED, third as a verb. In other words, we're cutting the distance. So D is 1/3 of D sub naught. What changes? Well, what stays the same? That's probably easier first to start out with.
Charge.
Yeah, disconnected, charge is gonna stay the same. So that's 2 Q sub naught.
The voltage.
No,
No, never mind, that voltage.
voltage will decrease by a third.
Well, no, the voltage should increase because it's a fraction.
No, voltage increases when distance increases.
Why don't we do capacitance next?
Increases, yeah,
By
a third.
by 3. Yeah, looking at this right here, kappa stays the same, epsilon not the same, area of plates is the same. D is what, it's been cut in a third, so the capacitance is triple what it was before. So this is now 6 C sub naught. So if I know the charge and the capacitance, I should be able to figure out the voltage. So the capacitance is 6 what I started with, and charge is twice. Pardon? Go up by 3? Well, looking at this, does that work? So we have, if I know the voltage is Q divided by C. So my voltage is now V naught divided by 3.
Electric total stays the same.
Total?
Yeah.
Why?
Because it's just the delta voltage, it's just voltage over distance in the same ratio.
Okay. And for the plates?
Would decrease by a third?
It's gotta be bigger than that. You said increase by 3?
6 epsilon naught, yeah.
Well, I know that from the plates, it's sigma over epsilon sub naught. Or actually, kappa epsilon. Sigma is Q over A. Kappa epsilon. Or kappa epsilon sub naught, that's right.
Isn't that the total?
So it's Q over A kappa epsilon sub naught, that's total.
Okay.
So Q is twice what it was before. K is twice what it started with. Right, something's off there. So if the charge is doubled, okay? Area's the same.
Let's see what events on this.
Oh. This is just from the plates. There's no kappa there. Is that what you were trying to say earlier? Sorry about that. Area's the same, epsilon naught's the same, Q has doubled, so this will still be 2. At some point over the course of the years, I'd give problems like that, and usually with numbers, you do the calculations. And then at some point I thought, we gotta do something different, I'm tired of that question. So I changed it around and I have a capacitor and I want to double the capacitance and cut the charge by half. How do you do it?
Say that one more time?
If you, I want to double the capacitance and cut the charge on the plates by half. And then I gave you a list of things that you could manipulate. And if it's not possible, show why it's not possible.
How long do people sit on that question?
Well, the first time I did it, I said, how would you do this? And one of the problems was impossible,
Oh,
because I made a careless
Nice.
error. So then I changed the problem the next time I did it with, if it's not possible, explain why.
You,
So is it even
increase the
possible?
voltage by 2?
If you increase the voltage by 2,
You have to decrease the voltage by
Uh,
If you wanna increase capacitance but keep take half the charge, you have to increase voltage, decrease voltage by 4.
so voltage gets decreased by a factor of 4, so this is half.
no, all you
This
do
is
is
a
increase
four.
voltage by 2, and then you multiply the 2 to the other side and you get 2C. Which is what we want, right? 2 times capacitance.
But we need to cut the charge in half, that was the other part of it.
That's where you started, you had, 1/2 Q, move the 2 to the bottom, move the 2 back to the C, you have 2C equals Q. My bad algebra.
So you were saying, cut that in half, so I now have
C equals 1/2
Q over 2 delta V naught.
Yeah,
My capacitance is half what it was. Not double what it was.
yeah, bad algebra.
But the question is, how would you get the charge cut in half anyway? You can't just say, I'm just taking half the charge off. You have to manipulate something in order to do that, increase the distance. Well, first off, my charge is changing, so we're gonna be hooked to a battery. Whether we disconnect at some point and then reconnect, and I also know that my total electric field, that's the decent T, my total electric field is gonna be equal to the voltage divided by the distance between them. Or let's see, delta V equals dEd. I know my capacitance is equal to Q over delta V, which is just my electric field D. If I don't use a dielectric in here, then this becomes Q over Q over Q over A D.
Wouldn't you be able to just keep it on a battery and then decrease voltage by half while it's still connected, disconnect it perfectly, then decrease the distance by half?
If I decrease the voltage by half,
Yes.
then my electric field, the total electric field will be cut in half. Because of this relationship here. So if that's cut in half, that's cut in half. Which means that my charge has been cut in half.
We're trying to get 2 times capacitance and half the charge.
Yeah.
Couldn't we just do 2C equals 1/2 Q and then solve for V?
So double the capacitance
which is what we want, and then
Right.
half the charge. So two C equals 1/2 Q.
So if we
over
start out
V.
with, that's my initial value, right there, I'll just put V sub 0, those are my initial values.
I guess I'm just wondering why we need to bring other things into it, when we can just substitute what we want in the original equation.
Well, the things that you can manipulate the physical things on it. I need to do something with, I have distance, area, dielectric, voltage, those are the things that I can manipulate.
Well, we still have voltage in the equation now, so
Alright.
we just replace the other two variables with the variables that with like, scaled versions of the variables we want and solve for V.
So V naught is
Or is it
equal
gonna
to
cancel out?
Q naught over C naught. If that stays, though, you're suggesting dropping this,
I guess in your, let me see if that just cancels out, it makes no sense. Be 1/2 Q over 2C, so be Q over 4C.
so if I cut this by 4, or if I quartered it,
I don't know.
I mean, that still works like that. However, if that is dropped, if the charge is dropped by half, my total electric field is dropped by a half. And if, okay, there we go. So if you were, it sounded like you were suggesting just, how do I get 1/2 and then 2? So in other words, my voltage, somehow I have to manipulate something to get a quarter of my original voltage. So turn the dial down. But if I change the voltage to a quarter of what it was, my total electric field gets cut by a quarter. My total electric field gets cut by a quarter, without doing anything else, then the charge on the plates is cut by a quarter. But we need it cut by a half.
That's why you would cut voltage by half first. And so the charge gets cut in half. And then you disconnect it, so charge will stay the same no matter what. And then you can decrease distance.
But if I decrease distance, still connected to the battery?
No, it's
So you
no longer-
disconnect it.
Yeah,
Alright,
disconnected.
so cut the voltage in half. Capacitance, none of those change, so capacitance is still the same. So my charge is cut in half. Now disconnect, so I have half the charge, and then I can,
Decrease distance by half.
yeah. I think that'll do it.
Good job, Paul.
Fun with capacitance. Alright, we're about to have some more fun with capacitance, and I know you're going, there's only so much I can take, but I think your hearts can take it. And if they can't, I will apologize to your family. Alright, let's do it. So I'm gonna take my parallel plate capacitor, and I'm gonna rewire it slightly. I've got my battery here connected to the parallel plate. And right here where it's connected, what I'm gonna do is I'm just gonna split the wire. They're still both connected to the plate, nothing there has changed. So my capacitance is still kappa epsilon sub naught A over T. Then what I'm gonna do is I am going to split the plates. A small little cut in it, we assume that there's nothing flowing between them, no sparking, etc. So the plates are now smaller in size. So that distance and that distance add up to what it was before. All that Y1, Y2. There's a width of W. So initially, the plate, the area of the plate, was the total distance, we'll just say Y, times W. And now I have two plates that are smaller, where Y1 plus Y2 equals Y. So looking at this, I have kappa epsilon sub naught D times y1 plus y2 times W, let's do it this way, y1W plus y2W, which is kappa epsilon sub naught over D y1W plus kappa epsilon sub naught y2W over D. That's just the area of that plate, and that is just the area of that plate. So this just becomes kappa epsilon sub naught A1 over D plus kappa epsilon sub naught A2 over D. In other words, I have two capacitors here in parallel. And the total capacitance is just the capacitance of the first one plus the capacitance of the second one, which is what you dealt with on last Friday. Parallel, if I have a current flowing along here, it gets to this point, there's a junction, it's going to split one way or the other, and then we'll rejoin up on the other side. Those are parallel components. And so for capacitors in parallel, well, the equivalent capacitance is just the capacitance of first plus second plus the third, so on. Now, if I take my capacitor, I have some capacitance there, and now what I'm going to do is there's some distance between them, D. I'm going to separate the plates. And add a bit of wire in place in the middle like that. I will call this D1 and D2.